Okay, so here is lab 3.1, and the idea here is to build what we can think of as a light alarm. The idea is that we're going to have measure the amount of light that's shining on a CDS cell, and that's going to be fed into the non-inverting input to an op amp. And the op amp is running open loop, no feedback, so it'll function as a comparator. And we'll be comparing that to a reference voltage, so that when the voltage associated with the CDS cell voltage divider, and I'm going to call that VL for V light. When V light exceeds a reference value, the output of the op amp will go high, and that will cause an LED to glow. And on the output circuit, we'll have a resistor here, and we'll have to set that at appropriate value so that we can get a decent glow from the LED. Okay, so just starting left to right, I have the 6-volt battery that we always use. And by now your batteries may be starting to get weak. You should measure them. If they're below about 5.7 volts, it's time to throw those away and get new batteries. Okay, we have to decide on an appropriate value for this resistor here. And we're going to do that empirically. I'm going to start out just building this voltage divider, and I'm going to see what that light voltage is. And I'm interested in what that is when it's dark, and then I'm also interested in what it is during the ambient conditions and also when it's bright, meaning when I have a flashlight shining on it. Now, the problem statement here makes it clear that this circuit has to provide a low output, that is, this LED should be off, during ambient lighting conditions. So right now I'm sitting here in the room and I have an overhead light and I have some fairly bright ambient light shining on the CDS cell. So I have to configure this circuit so that whatever that voltage is for ambient conditions, this reference voltage has to be higher. And in that case, the output of the comparator will be low. And whatever value I choose here, I want, when I shine my bright light on here, I want this voltage to exceed this reference. And so starting out, I'm kind of thinking I'd like to have a reference value of around 3 volts. That way I could have equal resistors here in this voltage divider. I might use 1K for each of those. Doesn't really matter what I use as long as they're the same. Then I'd have a very convenient reference of 3 volts. That would only work if my VL for ambient conditions is below 3 volts. So the first thing I'm going to do is I'm just going to build this part of the circuit, and I'm going to see what that voltage looks like during ambient conditions. So here's the circuit. I have my CDS cell here. I'll put that in the board, and I've decided to start out with a 10K resistor for the other half of this voltage divider. So I have the CDS cell voltage divider, and what I'm going to do is, before I connect the rest of the circuit, I'm going to get my meter here, and I'm just going to measure that voltage right there so I can characterize what the ambient light situation is in the room. So I'm hooking up my battery clips here. Or not my battery clips, that is I'm hooking up my alligator clips. See if I can step out so you can see more of what's going on. Okay, I'm hooking up these clips. It's a little messy as always. But this is going to allow me to measure that voltage. I'll put the meter on, and then I have to hook up the battery. Okay, so I've got quite a high voltage during the ambient situation. If I cover this up, that voltage drops down quite low, right? It's going to get down to about half a volt. I could probably make it even lower if I covered it better, but that's not the point. The point is, during ambient conditions, when I just have my strong overhead light shining on that, I'm up at 5.25 volts. Now, I can make it go higher when I shine the flashlight on there. It'll go up to 6.2, which is as high as it can possibly be because that's the battery voltage. But I would like this voltage to be lower during ambient conditions. So what I'm going to do is I'm going to replace that 10K battery with a 1K battery. I'm sorry, battery. That 10K resistor, I'm going to replace the 10K resistor with a 1K resistor. And now I have an ambient voltage of 2.17. So just sitting here in the room with the overhead light on, the voltage is 2.24. And I'm going to write that on my note. It's 2.24 volts. I've written that there. And when I shine my bright light on there, it'll jump up to around 6 volts, 5.7, 5.8, around 6 volts. I'll go with 6 volts. And then just for reference, when it's dark, it's quite low. It's 0.15 volts. Okay, so and I have to change my original circuit here. I had noticed that I originally was using 1K. 10K. I'm gonna replace that with 1K at this point. Okay, so now what we learned empirically is when using this 1K resistor here for this half of this voltage divider, during my ambient light situation, I have 2.24 volts. And then when I shine a bright flashlight on there, I have 6 volts. So that means that I have to set this reference above 2.24 volts. And as long as that's above 2.24, then the comparator output will be low. So by setting these two identically, let's say 1K, the value doesn't matter, but I can use 1K, then I'll have 3 volts in between them. So then that ought to keep this off during ambient light, and then it ought to turn on when I shine bright light on the CDS cell. So now I'm going to go ahead and build the rest of the circuit. And I'll take the multimeter away just so it's not kind of cluttering up the picture here. Okay, I have my LM358 IC. Now the first time you put one of these in a board can be a little tricky. You may have to kind of fight with the pins a little bit to get them in. And remember that the dimple on here tells you where you have pin 1. So this is pin 1, 2, 3, 4, and then coming around the back side, 5, 6, 7, and 8. Now, on my circuit drawing, I've indicated how we're going to hook this up. Right? This is the schematic for the chip. Pin 1 is, and we're using this op amp. Remember, this chip has 2 op amps in it. So we'll ground pin 4. Pin 8 will go to our VCC of 6 volts. And then pins 2 and 3 are the inverting and non-inverting inputs, respectively. And pin 1 is the output. Now, to help myself build this, what I've done is I've translated these pin numbers here over to the chip itself. So starting over here, I have VCC, that's pin 8, and I've noted that that's pin 8 here. Okay, and then I have pin 1 is an output. I've noted pin 1 here. Pin 2 is the negative input, or the inverting input. Pin 3 is the non-inverting input, and pin 4 is ground. So now I have all the information I need to go ahead and hook up that chip. I'm going to take away the battery so things aren't powered up as I'm building this. And I need to power this up. So on pin 8 is going to go to my plus 6 volt rail. Pin 4 goes to the ground rail. Okay, now this voltage divider that we just tested and built, that's going to go to pin 3. 1, 2, 3. And then I'll need to build this branch here. So I'm going to get 2 1K resistors. I'm going to connect one of them to the positive rail and the other one to the ground rail. And the node in between, I'll connect that to pin 2. So there's one of them. It's a little messy, but you can see what I'm doing there. So you see I have those 2 resistors, and at that node in between I'll have 3 volts, because I have 6 volts dropped across the series combination of the 2, so I'll have 3 volts right there. So 3 volts there, and that's going to go into pin 2. Okay, now we're almost finished, except that we have to hook up our output. So the output is pin 1. It's going to go to an LED. And I'm using a 1K resistor here to ground. So when I fire this up, power it up, what I would expect is that the LED would be off, because I just have the ambient light shining on the CDS cell. And then when I shine bright light on it, I should have the LED glowing. Okay, so far so good. Okay, success. Okay, so remember, the important thing here is that you don't want this output to be going on. You don't want the circuit to be alarming during bright ambient light. Now, if I change the ambient light situation in the room, then that's going to actually change my circuit, because right now this circuit has been tuned up for the existing overhead light in the room. But I have another lamp that I've set up over here. I could turn that on. Oh, and you can't see it because of the light saturation, but that LED has gone on. Because what happened is I've now changed the ambient light, and I've got this additional, well, let's see if I can show you this big old lamp here. I got this additional big old lamp, and that is throwing more ambient light on the circuit. Normally I don't have that lamp here on the lab bench, but I just included it to show you the effect of changing the ambient light. Okay, so once again, when I bring my bright light on there, then the LED turns on. Okay, now the LED is certainly on and glowing when I have bright light on there. It's not glowing particularly bright. And the calculation that I had done here says that, well, when the output of the op-amp is high, then I should have 6 volts there. And I know that I drop about 2 volts across an LED, so that would be 4 volts across the resistor. And I chose a 1K resistor, so that should give me 4 milliamps. Actually, the LED is pretty dim, so I'm going to go and measure what this actual voltage is, because we know that sometimes the output of an op-amp is going to be lower than the VCC voltage, because there is some voltage that's dropped inside the op-amp itself. So what I'm going to do is hook up the multimeter, the voltmeter, to measure that output voltage there relative to ground. Okay, and right now it's reading 0. Bring my light onto it, and it's jumping up to 4.81. So now the output of the op-amp is only 4.81 when it's high. The battery voltage, let's measure that. The battery voltage here from that rail is 6.25. So 6.25. I'm just going to make a note that the output of the op-amp when high is 4.8 volts. And when low, it's 0 volts. And so what that tells me, when I go back to this circuit, I have 4.8 volts when that's high. That means I'm really dropping 2.8 volts across that resistor. So I really only have 2.8 milliamps in there. I could change that from maybe a 1K resistor to a 100 ohm resistor, and that would make it quite bright. With 100 ohms instead of a kiloohm, then I'd be at, instead of 2.8 milliamps, I'd be at 28 milliamps. Now, mind you, the circuit was fine as it was. I don't need to change this, but I'm just looking at ways of making it a little bit brighter. Okay, so it may or may not be apparent from your view looking at the movie, but it's quite a bit brighter here with that 100 ohm resistor compared to the previous 1K. But either of those resistors is fine. Okay, so that is circuit 3.1, and let's go ahead and complete what we had on here. I'll note that we had 1K. Okay, so I just wanted to capture all the information that we had just sort of gleaned from the circuit. So I used a 1K resistor here, and we found that the light voltage was 2.24 volts during ambient conditions. It went up to 6 volts when it was bright, and then down to 0.15 when it was dark. I used a couple of 1K resistors here to give me a 3 volt reference. I didn't actually measure that reference, but I expect it's right around 3. Then we also looked at the output of the op amp, and I've also documented that it was 4.8 volts when high. And I used a 100 ohm resistor in that place. So I just wanted to document that. Okay, that's the end of that circuit.